Hello and welcome back to another episode of Teach Me in 10. For this episode, we're joined by Professor Konrad Kording from the University of Pennsylvania. Konrad explores one of the biggest questions surrounding artificial intelligence today. Can AI really read our minds? He explains what neuroscientists actually mean by decoding brain activity, how AI interprets brain signals, and where the boundary lies between scientific reality and science fiction. Hi, Konrad. Thanks for joining us. So I thought let's start with the basics, as the phrase AI can read your mind gets thrown around a lot these days. But before we talk about what's possible, what do neuroscientists actually mean when they talk about decoding brain activity? Is that the same as reading someone's thoughts?
Conceptually, what we do when we do mind reading is that we first produce a data set where we ask you to think certain ways. So, for example, when it comes to moving your hand, we might ask you, imagine moving your hand forward. Imagine moving your hand backwards. And then at a later point of time, when you actually want to move your hand, we assume that the activity in your brain when you move your hand is similar to the activity that you have if you want to move the hand in a certain way. So then what we do when we do mind reading or brain decoding is that we take times where the brain looks like you want to move your hand forward. And we say, well, that's a time where you want to move your hand forward and times where you want to move it backwards. And we just say, if the brain activity looks the way it looked when I asked you to do that movement, then we say, well, probably that's what you want to do at that point of time. So, or when it comes to speaking, you can say, I might ask you to say the, say he, say she. And then we can say, well, when you say the, your brain activity is different from when you say she. And therefore, if the brain activity is more similar to she, you'll probably want to say she. And when the brain activity is more similar to the, we assume that you want to say the. So that is the basic idea.
Right. And how does this actually work? Like if I have a thought, say I'm imagining my childhood home or deciding what to have for dinner, how does that become something that AI can analyze? What kinds of brain signals are we actually measuring?
Yeah, so we first need to get some signals out of brains, and there's multiple different ways how we can do that. We can do it just externally, where we have a video that looks at you. Sometimes I can estimate what someone, for example, if someone's listening to me by just looking at their face. And then there are the minimally invasive techniques, think EEG, where we put electrodes onto your head that measure electrical signals, all the way to very invasive signals, where like if we have, there's these so-called brain gate trials where they put a lot of electrodes into someone's brain, someone who cannot speak anymore or someone who cannot move their hands anymore. And then we give them a prosthetic device for their arm, or more recently, a prosthetic device that speaks because they can't speak anymore. And all of these, the more invasive we are, the more we put into the brain, the better the signals. The more we are on the outside, going towards only a video of your face, the lower the quality of the signal. And then we have the signals that we get from there, then we can see what we can decode from it.
Right. So what is actually possible at the moment? As the headlines often make it sound as though AI can reconstruct our inner lives. But in reality, what are the most impressive things we can reliably decode from brain activity today? And what still remains firmly out of reach?
The most impressive things, I think, is what happened over the last year, 2 years, or something like that, where we start having rudimentary speech prosthetic devices, where you can say, we are asking someone who can't speak, just imagine you'd be speaking. And if they imagine speaking, we can pick up the signals in the brain. We're like, yeah, this signal in the brain is just like when they want to say the, therefore it's probably the, and therefore let's let the loudspeaker say the. And that's the logic of that. And so the most impressive things, I think, is reproducing rudimentary speech. Now, let's distinguish two kinds of mind reading. There's the mind reading that we can do at the moment, which is you're trying to say the or house. And I'm trying to find out, is it the or house? There's the other part of mind reading, which is the memory that you have to the house that you had at home. We can't read out these things at all. No, so it's not really mind reading. It's more like it is reading the process of what you want to do on the inside. It's probably very much picking up on if you say there's the th and there's the e, and there might be even like kind of like a connotation of when you say then afterwards comes content. It's using a lot of that broad distributed brain activity. It's like it's listening in on your inner voice. But listening into your inner voice is different to reading your mind.
Yeah, absolutely. It's fascinating. But yeah, speaking of that sort of level of understanding, one of your most influential papers showed that if you analysed a computer processor using the same methods that neuroscientists use to study the brain, you could find patterns without really understanding how it worked. And today, AI systems are much better at finding patterns. Do you think they help us move from finding patterns to understanding systems, or are they just giving us more powerful tools for the same problem?
I think we're seeing the development of two completely different kinds of science and engineering. You can say traditionally, if I do brain science, it leads to insights that I can explain to you. And then once you understand what we took from it, you can look at other brain questions and you will have empowered yourself to be better at understanding that. Where you can say, for example, we often find that there's activities in the brain that correlate with outside things. We know that there's certain brain states that correlate with you saying the word the. And if I know that, if I understand that the inner properties of your brain relate to outside properties, say the next word that you say, that empowers me to make predictions in new situations. You can say, well, what happens if you now say a different word? Well, there's probably going to be a different part of the brain active. Brain activity will be different. So that's traditional science. It's like an intuition path for you. We read the science and it makes us better at thinking. Then there is this, what I call machine science. Think AlphaFold. Now, AlphaFold is amazing. You tell it the sequence of a protein and it tells you how the protein will fold in 3D space. They get the Nobel Prize for it, like incredibly cool research. But it produced no insight. It wasn't that it got us into new principles, things that we can use. It's doing the thinking for us. And both of them are useful. Now you could say, if I ever lose my voice, maybe the nerve gets cut because I have a tragic ski accident or something like that, and I can't talk because the nerve is cut, then please give me a prosthetic device that restores my ability to speak. And I don't care if you understand how it works, as long as it talks for me instead. That's great. But you can say that doesn't lead to an understanding of how my thoughts translate to speech. It's just, if you want, it's engineering. It's think for us. It's not think with us. So I think we are moving into a future where there are problems that we can solve with large amounts of data, AI and all that allow us to solve problems. And that's great, but they won't to the level that current human science advances help us think through the world that is around us.
Yeah, that's a very important distinction to make, because all of this raises questions about privacy. Whenever people hear the phrase mind reading, the conversation quickly turns to privacy. Based on where the science really is today, how worried should we be about AI accessing our thoughts?
So again, it depends on what you mean with AI accessing your thoughts. I think that it's quite likely that midterm security services will be trying to read our inner language. I happen to not have inner voice, so therefore it completely avoids that problem. But I presume most people, if they close their eyes, they can they talk with themselves. And therefore, it's possible to decode things entirely against the will of a person. So if someone has inner monologue and we have access to their brain data, probably it's possible to decode it. Probably somewhere in the world there is there's a secret service lab that is working on this at this point of time. And this is something that's very worrisome, and we probably need laws that outlaw that from my perspective. But then there's the other part, which is kind of could someone decode all the thoughts that sit in my head, all the things that has happened to me, if you want, my whole life? I don't see how current brain recording technologies would support this.
Right. And finally, let's look into the future. If we had this conversation 10 years from now, what do you think AI will genuinely be able to tell us about the human mind that it can't today?
So I think AI doesn't tell us about the human mind and never will, but AI is a tool that we use for that. So for example, AI is a tool that we use to ask, how does what happens in the world relate to our brains? It's incredibly good at that. Now, if I want to ask, how does the brain causally work? How does this thing influence this thing? I think we understand today that if we want to ask how this causes this, we need to go in and do something here to see what happens there. But these dependencies between what I do to a system and how it behaves, they're complicated. And if we deal with complicated statistical relationships, we will need to use techniques that we traditionally call multivariate statistics, that we call AI today, because this is the only tool that we have to see structure, if you want, in high dimensional data. And so I think AI itself is a tool that we will use for everything in science in the future, but it itself doesn't answer these questions.
Such a fascinating topic, and there's going to be a lot more research coming out, I'm sure, about this. But Konrad, thank you so much for joining us and sharing your time and your insights. It's been really interesting.
Thanks for having me, Laura.
Thank you. Thanks for watching this episode of Teach Me in 10. To learn more about AI, neuroscience, and brain signal decoding, check out the links in the description. And if you enjoyed this episode, don't forget to like and subscribe for more episodes. Bye for now.